Welcome. It's great to see so many familiar and new faces here tonight. It's been a minute since the last time we did this, and I think it's always really great and healthy to have in-person events like this. I work remotely for Meteor from Brooklyn, and so my days are like filled with hanging out with my dog and working on this JavaScript framework, and so social interaction is just really rejuvenating for me. But I'm in town just for this, and that's my name. That's where we are. I've managed to snag the username Benjamin without the I on most forms of social media, including slides.com, which is this amazing presentation framework that I used for these slides. Well, you can judge for yourself how amazing they are, but it worked. Anyway, like Lucas, I had trouble coming up with accurate, like content-specific title for the talk. Meteor 1.7 is just a number, and not even a very exciting number all by itself. But what I really want to tell you about is like the most incredible new thing that I feel like we've done with Meteor since the last time I gave one of these talks in person about 3 years ago. We've managed to find a way to compile code just for the very latest browsers without dropping support for older browsers, which is a balancing act that no one else seems to have accomplished yet anywhere in the JavaScript community. So that's what I'm going to be telling you about tonight, and some talk titles that we were spitballing at the office were different bundles for different folks. One size need not fit all, and my personal favorite, running with safety scissors. Meteor is all about that safety. So yeah, 3 years ago, intense waves of deja vu right now. I stood in front of a similar room and gave a similar talk, even on some similar topics. I felt under pressure then to justify a pretty big decision that we were making, which was to start using Babel and the ECMAScript Meteor package, which many of you have probably used quite a bit since then, to compile Meteor code before sending it to the client so that you could begin using new JavaScript syntax that had been proposed or specified but was not yet universally available in all browsers. And that was a big step, because before then you would just write your code and it would run in the browser as is, and you would have to deal with any inconsistencies in browser support yourself. And so adding another layer of indirection where we started changing that code before it ran in the browser seemed like a big deal. But in the intervening 3 years, the practice of compiling code before running it in the browser has become literally ubiquitous, and so I think that choice has been richly validated since then. But in service of justifying that decision, in that talk, one of the promises that I made was that if Meteor starts supporting a new JavaScript language feature, like say class syntax or generator functions, and you see a blog post about that, you start writing code using that syntax, then our promise is that you would not have to rewrite that code when native support finally catches up in all the browsers. You just start to benefit from the native support running the same code without compiling it. And I wasn't sure when that day was actually going to come, but I had faith that it would eventually come, and knew that if we stuck to this, then we wouldn't be sort of like luring people into trying something out that ultimately needed to be rewritten. So where are we now? Well, 3 years later. It's quite a long time in JavaScript. It seems time to pose the question, has native support actually caught up yet? And I'm happy to say that while the answer to this question is definitely yes, so many of the things that used to have to be compiled before running in the browser can now just run directly in most recent browsers. This related question, can we stop transpiling yet, is paradoxically a definite no, right? So how is it that like native support has caught up, and the whole promise was that eventually you were going to stop having to transpile your code because native support had arrived, but we can't stop transpiling, and in fact can't ever stop transpiling. Well, that's the world we live in, because this whole process of JavaScript standards and browser vendors is not approaching an asymptote. I mean, perhaps one day JavaScript will be complete and the TC39 standards committee will, disband its meetings. And at that point, major browsers will all catch up to that point, and you'll be able to stop using Babel or other tools like TypeScript to compile your code, but that's not happening. And my hunch is that forever there are always going to be shiny new JavaScript features in the future that you want to try out today. And so the kind of progress that we're making is that features you're using today, yes, those features will eventually become natively supported, but there will be a continuous stream of new features that you'll want to keep transpiling. So it's an ongoing process that has no end, and that's great news for our job security. So another way of unraveling that paradox is to observe, as William Gibson did, and supposedly William Gibson in 1993, supposedly, that the future is already here. It's just not very evenly distributed. And this is true of a lot of things like income inequality, as well as JavaScript, browser support. But the natural follow-on question is just how unevenly distributed is this future that we find ourselves living in? If you'd told me in, say, 2006 or 2007, in the heyday of Web 2.0, when I was an intern at Meebo, the instant messaging startup, that a future was coming and made me guess what kind of future that was going to be, I think I could have believed you if you told me that this possibility number one was what was going to happen. So, every browser just kind of goes its own way, picks and chooses the JavaScript features that they want to support at their own pace, with their own meandering history of, partial support along the way. That's, I think, a totally plausible alternate history that thankfully has not happened. Another possibility, even closer to the truth, honestly, is that a single browser vendor might have emerged victorious over all the others. I probably would have thought that it would be Firefox in 2006, 2007, but today the browser that seems closest to that reality is Chrome. And if you do control the entire browser market share, you kind of set the de facto standard for web compatibility, and then web developers just have to do whatever you make them do. So that's a dire possibility that I think we have avoided, although Chrome's market share is increasingly impressive. A third possibility, also plausible, is that browser vendors might, over time, mostly come to agree, thanks to the JavaScript standards process, on what JavaScript should be and what web standards should look like, but many users might still be stuck on older versions of browsers, either because they can't or won't or don't know that they should update to the latest versions of browsers. And then possibility number 4 happens to be, I'll spoil it, I think, the truth, and I'm going to unpack this in the next couple of slides, but it's something that I don't think I could have anticipated back then as a web developer, that a new class of evergreen browsers would emerge, leaving the vanishing minority of nevergreen browsers, no one uses that term, but I think it makes sense here, increasingly far behind. So what do I mean by that? Have people heard of evergreen browsers? Is this a thing that, yeah, it's the best news. After coming to understand what this meant as a 2006 web developer, I would have been thrilled to hear that this is actually what happened. So what makes a browser evergreen? What does this word even mean? Well, it's a browser that keeps itself updated automatically. When I worked at Mozilla in 2008 through 2010, Firefox was definitely not an evergreen browser in this sense. You had to go into the settings and explicitly choose to update to the next version. If you have a browser that just actively keeps itself updated all the time, then there's no reason it can't support nearly the entire ECMAScript language specification. So these browsers that are in this new class of aggressively self-updating browsers basically don't have any gaps in their ECMAScript support, at least as far as what's been specified as of ECMAScript 2017 is concerned. And in another sense, something that all of these browser vendors share is that they're involved in the process, right? Like the reason that they're actively shipping these updates is so that they can figure out if this stuff works for people and give feedback into the standards process. I am a delegate to TC39 standards committee meetings, and most of the people in the room are representing browser vendors, and they all have very clear-cut insights from the literal experience of having shipped the features that everyone else was just talking about and getting real-world feedback from their users. And these are web browsers we're talking about, so that's billions and billions of users. So who are the evergreen browsers? Well, Chrome is a great example. Chrome sort of pioneered this practice. There's also Firefox now in that category. Microsoft Edge, right, which is distinct from Internet Explorer, is an evergreen browser, and that's great. I really applaud Microsoft for taking this plunge. They're distinctly uninterested in updating Internet Explorer itself, but it's understandable. They want people to use the new browser. And then this is Safari's logo, but it's sort of purple, right? Like that's the logo color scheme for Safari technical preview. So what I'm trying to say here is that more recent versions of Safari have joined this game, and that's great. So what about these nevergreen browsers that just won't change? Well, of course, there's Internet Explorer, IE 10 especially, and earlier, and older versions of Safari. Now, a major caveat to give here is that while Safari has not always been an evergreen browser technically in the sense that it keeps itself updated, the Safari version is tied to your Mac operating system version, especially on iOS, and Apple is great about getting people to update to the latest version of iOS. So compared to Android especially, most iPhone users are using the latest version of iOS, which means they're using the latest version of Safari. So that's almost as good as Safari keeping itself updated. So I don't mean to shame Safari as much as I'm shaming Internet Explorer on this slide. So the truth of the matter is that these classes of browsers are within the class more similar to each other than well, they're very similar to each other within the class in terms of their support for JavaScript features. So that chasm is widening, and if you're still building just one client bundle for all browsers that you want to support, which probably includes older versions of IE and Safari, then you are, not to sugarcoat it, holding the majority of your users hostage to the needs of those ancient versions of Internet Explorer and Safari. Cool. And yet, that is exactly what most frameworks and applications do today, even if they use this tool called Babel preset env, which purports to give you a bundle that's tailored to a certain set of browsers that you want to target. That's helpful for not having to guess which Babel plugins are appropriate for those browsers, but you still end up with one bundle that you're going to send to all of your clients. This is an embedded iframe with some explanation of what that's all about in case. Yeah. Anyway, and I understand. This is a choice that makes sense to me. The alternative to shipping one bundle, which is shipping more than one bundle, is pretty daunting. Not only do you have to build multiple JavaScript and CSS bundles for different browsers with different dependency graphs and compilation rules and Webpack configurations, but your server also has to be able to detect the capabilities of each visiting client at runtime so that it can deliver the appropriate assets to those clients. And then testing, right? We're all responsible web developers here. Testing a matrix of different browsers and application versions gets cumbersome. So it's no surprise that if you consider yourself responsible, you would rather ship a single well-tested bundle and forget about taking advantage of modern browsers and their native capabilities until the legacy browsers have disappeared completely and you can just ignore them. Okay, so here's a word. Ontology is sort of your like personal understanding of like what the relevant objects and ideas in the world around you are and how they relate to each other. And it's sort of subjective. There's actually no like official ontology out there. Encyclopedias be damned. So when you make a choice about how to think about what the categories are in a design space like that of web development, your idea of like what counts as a useful category informs all of the designs that follow from your sort of understanding of the world. So if you have the idea that the relevant categories here are each different major browser, and so probably you're going to be building a bundle for each browser, then that's 4 or 5 or 6 browsers, depending on how far down the long tail you want to go. Or double that if you want to make a distinction between older and newer versions of those individual browsers. And I think you'll see from the rest of this talk that becomes pretty untenable pretty quickly. You could also maybe build different bundles for different ECMAScript feature sets. Maybe you decide that like a couple browsers support like a cluster of JavaScript features, and you want to target that with one bundle, and then like target other browsers with a different bundle, and older browsers with their own bundle. That's another ontology, another belief about the world that you could have that could lead to a certain design here. What a lot of people do, honestly, is that they have one Babel configuration, and they compile all their code the same way, but they ship different polyfills to each browser. So things like array methods or the symbol type. Certain browsers need a polyfill to sort of pretend to support those things, and if you know that a certain browser doesn't need it, you don't have to ship that code to that browser. And that shaves a little bit of size off of your bundle, but honestly the most popular way of delivering polyfills is this library called core.js, and if you use the entire thing, it's like 125 kilobytes, and if you try to use like just some of it, you end up through all of the interrelated dependencies using most of it in spite of yourself, so like 80 kilobytes, and that's just not a night and day difference, right, relative to the amount of work that goes into that. So I guess you could also go to the far extreme of generating everything on the fly and trying to cache your previous results if you really believe that the nirvana state here is to give every browser exactly what it wants. Anyway, what I would suggest instead, in order to clarify your ontology, is to ask yourself 2 important questions. First, how many different bundles are you willing to test? And second, what native features really matter the most to you? So on that first question, how many bundles are you willing to test? Obviously, the fewer the better. Like, testing sucks. I want to stress here, like, 1 is always a valid answer. If you don't have the bandwidth to test all of the bundles you're generating, you should be shipping 1 bundle so you don't have to test more than that. And of course, 1 bundle can serve many browsers because you can do dynamic feature detection. You can write different code paths that get executed in different environments. So you can be really flexible, but then you end up with each version of that code in the same bundle. So there's just some cost in terms of how much code you're delivering over the wire. And of course, like, even if you have a couple bundles that are just very similar, but they are not the same, you still have to test them separately because, I mean, the nature of programming is that little differences end up mattering. So to the question of what native features really matter to you, some questions that you might ask yourself: what have you actually been using through compilation or otherwise? What features would you use if there were fewer drawbacks to using them? Like, maybe you've considered using generator functions to be prohibitively expensive because the compilation is really complicated and it sort of turns into a lot of code. But if they were natively supported, you would start using them, and that could be cool. How gross is the transpiled code? I'm the author of the regenerator transform that takes generator functions and yield expressions and turns them into an ECMAScript 5 switch statement inside of a while loop, and it's just like undebuggable. Like, people tell me all the time that they don't use regenerator, because of that, and I understand. When I wrote it, I was really hoping that it would become obsolete, but here we are. And also, is the native version really faster? Okay, we're gonna have to speed up a little bit here. Anyway, you can decide what native features matter to you, but in Meteor 1.7, our answers to these questions are pretty straightforward. We're going to have two bundles. That's worse than one in terms of testability, but not so bad in terms of testability. One bundle is tailored just for modern browsers, and another bundle works for all supported browsers, both modern and legacy. And that's a really important property because the legacy bundle is a reasonable fallback in any case. And what does modern mean? Well, it simply means any browser that natively supports async functions and await expressions counts as modern. And the incredible thing, even though async await was just standardized in ECMAScript 2017, how many browsers out there do you think natively support async await? Well, this iframe stole my focus. Do you see that number? It's 84.53. Yeah, that's almost 85% of the world has access to a browser with native async await support. That's mind-boggling. 85% is much larger than I would have guessed when I started this project, but it's not nearly enough to justify ignoring the remaining 15%. It's not 100%. The holdouts will die hard. There's a great article here you should read called The Slow Death of Internet Explorer and the Future of Progressive Enhancement by Alysta Part. The good news, though, is that modern browsers are not some small emerging niche, but the vast majority of your users are actually using these modern browsers, largely thanks to the evergreen trend. And of course, if a browser supports async await natively, it supports all kinds of other things natively. So a lot of things follow from this. Maybe async await was too strict of a requirement. How could we change that 85% if we pick something like I don't know, ES6 classes? Well, yeah, sure. More browsers support ES6 classes natively, all of 87%, right? So that's not really better. So the lesson is you can't aim low enough to make Internet Explorer 10 happy. So you might as well aim high. Meteor 1.7 lets you customize the modern legacy system to your taste. And if you're going through these slides afterwards, just please note there are some vertical slide columns as well as horizontal. If you're writing a Meteor package, this is the way that, I hope that's big enough to see, that you would have added client and server code separately before. Well, now you can add code specifically to the modern bundle or the legacy bundle or the server like before. And in Meteor applications, this is actually a brand new feature in Meteor 1.7 independently of the modern legacy thing. In your package JSON, you can specify entry point modules, so you no longer have to rely on file loading rules and the imports directory. If that doesn't mean anything to you, don't worry about it. But one benefit of this is that you can do something very similar to what you did in a package and specify entry points for modern and legacy bundles. Okay. So once you've specified those entry points, you've divided your code into modern and legacy, you need to enforce your assumptions. And so there's this set minimum browser versions function that you should call, where you get to say what it means for a browser to be modern in your application. Breeze through this a little bit, but effectively the minimum modern version for each browser is the maximum of all the versions passed to set minimum browser versions for that browser. Right? So all the packages in your Meteor application sort of collaboratively define exactly where this line is drawn. There's a Meteor is modern Boolean that you can use if you really need to, although I don't recommend it. It kind of doesn't give you the benefits of this whole system. So this allows us to use totally different Babel configurations for the modern and legacy bundles. The plugins that we use for Babel are just vastly simpler in the modern bundle because there's fewer of them. Yeah, this was a fun little example where I was talking about some of the error reporting that you miss out on if you're always transpiling let and const into var declarations. And I really just wanted to show this amazingly prescient picture of John Lennon and Yoko Ono. But we'll breeze through that. just as you can have totally different Babel configurations, you can have totally different runtime polyfills. The ECMAScript runtime client footprint for Meteor applications is so much smaller. This is it for the modern bundle, and I would have to click through to a very large file to show you what it looks like in the legacy bundle. And this is music to my ears. The modern bundle never needs to import regenerator runtime, which is no small library. Okay, so what's the bundle size impact? This is pretty dramatic. So there's a bug right now in our bundle visualizer. We just haven't updated it for multiple bundles. So this pie chart is actually showing both the legacy bundle and the modern bundle in one, but that actually works because it gives you a visceral sense of like how much smaller the modern bundle is. So 25% of the whole is this legacy, the modern bundle, and the rest, the 75% here, is the legacy bundle. And so much of that is due to, I don't know if you can see it, but core.js, right? And we're just using a lot less of that. I don't even know where it is on the modern side. So if you're not using the bundle visualizer, you should. This is the command that you can use. Okay, asset delivery. I would claim, like, you can build different bundles, and that's great, and now you've got a bunch of bundles, but how are you actually going to give the right bundles to the right browsers? Well, you need to detect at runtime what the capabilities of each visiting client are, and that's really hard. Right. So, yep. Bear in mind, it's not just the JavaScript bundle, but the initial HTML response that might be different between legacy and modern, dynamic imports, CSS, any other static assets. So our answer to this is that we use user agent sniffing. It's the only way to get it right in response to the initial request without doing any additional feature detection and HTTP round trips. It's really not as bad as it sounds, but that's mostly thanks to the simplicity of the rest of the system. Our task is a whole lot simpler than actually accurately identifying every individual client. Because every browser can handle the legacy bundle, we can always fall back to that if we're not entirely confident that a browser is modern. So at worst, like a fake spoofed user agent might receive the modern bundle by mistake, and that's just not the end of the world. Meteor handles every aspect of this. You don't have to think about asset delivery at all. So that's a virtue of Meteor managing its own web server, just a capability that's out of reach of most other web development tools. And everyone in the Meteor community will begin using this same system so that if there are problems, we'll be able to suss them out together. So asset delivery is actually the easy part in this whole equation, although it is the most challenging thing that I would expect other frameworks to contend with if they try to follow suit. So what if something goes horribly wrong? Well, that won't happen, but you're alone. You're not alone. I misspoke. You got several options. You could make the modern requirements stricter to fix the bug, or you could change how you compile legacy code. If you end up adding like additional code here to make that work, that's kind of okay because it's just the legacy bundle. You could also do the same thing to fix the modern bundle, but if you're trying to keep that modern bundle small, you probably don't want to add a whole bunch of additional code. You might just consider redrawing the line so that those browsers that can't handle a certain feature are considered legacy instead of modern. Okay, so that doesn't mean you should stop caring about legacy bundle size, but a lot of the benefits apply equally to both. So if you can, say, stop using an entire NPM package on the client, well, that immediately benefits both modern and legacy users. So a lot of those decisions are the same as they've always been. And I should mention, this legacy bundle that we've been talking about is the same thing that we've been shipping to every client in Meteor 1.4, 1.5, 1.6, right? So it's good enough today. It's just that the modern bundle is a lot better. We've deployed this minimal Meteor app website, which is an example of another Meteor 1.7 feature. If you run meteor create -- minimal, you'll get a very small Meteor app in terms of client footprint. And this is also a good way to debug, like on your phone, are you seeing the legacy bundle or the modern bundle? So a case study that I may or may not have time to go through is you could imagine adding a polyfill for the WhatWG fetch function, which is a way of performing HTTP requests that is cross-platform. What I really want to show you about this is in the modern implementation of this fetch polyfill, this is all the code there is. Modern browsers all have an implementation of fetch, right? So there's just no additional code. You can re-export the global fetch stuff, but that's all you have to do. And then in the legacy module that loads in the client, you want to import this wg fetch polyfill, and then do the same thing that you did in the modern bundle to export fetch and friends. And in the server, there's a different polyfill, totally different, node fetch. So this is all looking pretty similar, but what you also want to do in the server is enforce your assumptions about what it means to be a modern browser. So these minimum browser versions define which browsers have usable fetch implementations. And if you were to compare these to the versions that we specify when we're saying a browser has to have native async await, all these numbers are so much smaller than that. So these minimums actually don't end up impacting the bottom line much, but it's good hygiene to just be very specific about what exactly it means to be modern whenever you're implementing a package that takes advantage of this system. Okay, yeah. By the way, caniuse.com is a great resource for figuring out which versions of browsers support which features. So we're coming to the very end. Out of intellectual honesty, it's always important to ask questions like, why haven't other people done this? Like, why is this not a common practice outside of Meteor? Well, it really does require a cooperating web server. Like, if you're having to worry about asset delivery, then there's just a lot more technical debt surrounding a system like this. So it just may not be worth it to you. And so a lot of frameworks do not incorporate a web server because they're trying to be like lightweight and plug and play. But in doing so, they miss out on some opportunities that are unique to frameworks like Meteor that do have a integrated web server. Another fundamental problem is that NPM packages are, just by their nature, pre-compiled. The package author gets to decide how they're going to compile the code, and then you just kind of have to live with that when you install the NPM package. So if you want to recompile it for different targets, you're already starting with somebody's idea of the furthest compiled code that they thought was reasonable, and so you just don't have much leeway to decide how the code should be compiled differently for different environments. And the environments are diverging so much now that that question is becoming more and more important. So Meteor's package system, in being able to set up client and server logic and run those bits of code automatically, still has several essential superpowers. The whole compiler plugin system is unique to Meteor. That's how we're able to use totally different Babel configurations for modern and legacy. And I will say Ember.js is another JavaScript framework that sort of has a lot of the same attributes as Meteor. They're considering functionality like this. They've already got a system for building different bundles. What they don't seem to have yet is a solution for the asset delivery problem. But I'm pretty confident that given that they incorporate a web server and have a lot of the same advantages of Meteor, that they will catch up here. But best of luck to everyone else. Okay, if you're curious about that question of recompiling NPM packages for your own purposes in different ways that were not anticipated by the NPM package author, there's a whole sequence of options. It's an extremely contentious topic in the wider JavaScript community, but I think Meteor 1.7 has a pretty good solution. In essence, what you want to do is clone the package locally, maybe with a get submodule, and then make changes to it as necessary. And then if you run Meteor npm install with the local file path, that'll symbolically link it into your node modules. And Meteor 1.7 will compile the code in the package, but then also expose it as an npm package and node modules. So you get the best of both worlds. And often no changes are actually necessary, since all you needed to do was let Meteor do its thing and recompile the package codes that it doesn't use native class syntax anymore. Okay, so I'm going to conclude with a very brief meditation on this overhyped term that you've probably heard in the JavaScript community, zero configuration. What does that really mean? Well, Webpack recently shipped a major new version where they finally chose some sensible defaults for the truly Byzantine configuration API that they had been exposing their developers to, subjecting their developers to, if I'm being honest. And that's good. It means that the out-of-the-box experience with Webpack is better. But if you're really serious about reducing the amount of time that you waste on configuring your software, what you really want to be doing is eliminating the need for configuration. So if you find yourself with several options for how to configure something, but you realize actually one of those options is good enough for everyone, right? Like the other options, no one would ever choose them, then you could just remove that configuration surface area altogether. And that's a noble pursuit that is underrated. So picking reasonable defaults, again, is not enough unless they really do work for everyone, because you're just going to end up having to depart from those defaults if you get into sophisticated usage. What you really want to do is avoid centralizing your configuration, because if you have like one central package.json file or webpack config.js file, then the code that configuration has consequences for could be very distant, and the stakes for making any changes to that configuration file are like suddenly much, much higher, because you just don't know what you're going to break. And if you do change code in a way that means that some aspect of the configuration is no longer necessary, there's no linkage there. Like you don't know that you should go update the configuration, and so over time the configuration just gets stale. So what you really should strive to do is make the code that you write express the things that you would otherwise use configuration for. So like that set minimum browser versions function call, that's in the code that's actually defining how these things work. And so if you Meteor add or remove a package that calls that function, then it just automatically adjusts the definition of modern versus legacy browsers without any explicit manual configuration. So if you can automate reconfiguration, then you've greatly reduced the sort of lifetime cost of this configuration burden that every real software project faces. All right, how to update to Meteor? Meteor.com/install if you're doing it from scratch, or Meteor update. Little story, Meteor 1.7 was not working for everybody. So 1.7.0.1 is the new 1.7. You're going to want to update your Babel runtime package and the Meteor node stubs package. Those are NPM packages, by the way. And there are the full release notes, which you can check out at your leisure.